Osmosis is the movement, or we'll say the diffusion, now that we understand what diffusion means, of water across, or we'll say through, a membrane. And if you recall from the first couple of lectures, what is a property of a membrane? Well, a property of a membrane is that it is selectively permeable, which means that water passes through a membrane, but things that are dissolved in the water cannot. And so when we talk about osmosis, we're talking about water. We're not talking about sugar or salt moving across a membrane, because they will not be able to do that. That's just the nature of what a selectively permeable membrane is. Water is going to move from high to low. Now, in various textbooks, when they start talking about water movement and osmosis, instead of writing water concentration in brackets like this, they'll often use the Greek letter psi, and they'll refer to it as water potential. Okay? And water potential, for our purposes, basically means the same thing as saying high concentration of H2O and low concentration of H2O. So, in other words, this state equals high water potential, and this state over here equals low water potential. So, in order for osmosis to occur, just like diffusion, we have to have a gradient. And so osmosis will continue along its gradient until the concentration on both sides, or the potential on both sides, is equal, or we reach equilibrium. So let's draw an example here. Go back to our beaker of water. I'm going to use a dotted line here to represent a semi-permeable membrane. So if we could divide our beaker with a membrane like this, and we come in and put water on one side of the beaker, do we have a gradient? Well, sure we have a gradient. We've got high water potential over here on this side, and we've got low water potential on the right side of our membrane here. And so water wants to diffuse from side A to side B. And because this membrane is permeable, which means water can flow freely through it, that's exactly what water's going to do. And so the water's going to, through osmosis, move through this membrane to the other side. And over time, we end up with, I won't use red, but I'll just draw, you get the picture of what the dotted line means. Over time, we're going to reach equilibrium, okay, to where we have net movement in both directions, meaning that water potential is equal on both sides of that membrane. And so that's, again, we call that equilibrium. So osmosis causes the water to move from a high concentration to the low concentration, or potential if you want to use potential. And so eventually the water evens out on side A and side B. Let's take it a step further. Same scenario, but we're already at equilibrium. So here's my selectively permeable membrane, and side A and side B are equal because we filled it with water, and the water can move in either direction across that membrane. But let's say now we took some sugar, or let's say salt. Okay? Either one would work. If we add some to side A of the beaker, we've created a gradient. We've created actually two gradients. In terms of salt, we've got a high concentration on this side, and let me draw my line here, and a low concentration on this side. This is for salt. And in terms of water now, instead of being in equilibrium, we've got water potential on this side that's lower because it's not pure water anymore. However, on side B, we've got pure water still. And so we have high potential over here, low potential over here. And so we've got two gradients. Now, water wants to move from high to low, okay? And it can indeed move through the membrane. And so that's what it's going to do. The water is going to move from side A to side B. Now, what about the salt? Well, the salt wants to move from high to low, but because it's got this semi-permeable membrane preventing it from doing so, use a different color here, that will not happen. And so over time, here's what happens. Like we said, the water wants to move from side B to side A, and that's what it does. And so given a few minutes, the water moves to that side. Okay. However, the salt remains on its original side. Because it cannot pass through the membrane. And so water, by osmosis, has moved from side B to side A because of the salt concentration. Now you might ask, why didn't all of the water go to that side? Because we still have a water potential that's higher on this side than on this side. And the answer to that is water is going to move across and through that membrane until it reaches equilibrium, which we have not done here, or until the limit is reached for this side. And the weight of this water column, due to gravity, is going to provide back pressure to the movement of that water. In other words, the pressure that builds up on this side will prevent all of the water from moving into it. And the same is true inside of a cell. If we were talking about a cell, we basically got it's surrounded by semi-permeable membrane. Now, if we had a cell like a root cell out in the soil, a root hair cell, let's say, and we've got water out here that's high, relatively speaking, inside of a cell, the water potential is much lower because inside of the cell cytoplasm, we've got all sorts of things. We've got organelles floating around. We've got sugars dissolved inside. We've got various types of salts. And so water naturally, through osmosis, wants to move into the cell. And indeed it does until it reaches the limit of the cell volume, which is placed on it by the cell wall. So osmosis will move water, move it up a little bit here, into a cell until it reaches its volume limit, or H2O becomes scarce. Meaning, if a drought condition limits the supply of water to the cells, well then the cell may not maintain full volume. And when a cell is well inflated and fully inflated, we say that it is turgid. Turgid means inflated with water. Maintaining good turgidity or maintaining turgid cells is extremely important to plants in that it helps them prop their leaves up so they can be more efficient at capturing sunlight. And in the case of non-woody type plants, the cell turgidity is largely responsible for the plant remaining upright. And you may have seen this before with certain types of plants that grow fine upright above the ground, and then after a period of drought lay completely flat along the ground because they've lost turgidity in their cells. Now, this movement of water into the cells of a plant is the primary way in which water enters a plant from the environment. And that's what we'll talk about next time.